That guy had a haircut, like a real respectable haircut. I don't know. I feel like it's like a dating site bait and switch with what you're getting today.
So there we go. This Dan Cornell, he's one of our best local people down in San Antonio still, right?
Mm-hmm.
So yeah, he's a great resource we got here, and he's going to be able to talk to us all about the DevOps CI/CD and what should and should not be there, if I remember right. So I'm going to stop sharing and let Dan take over.
All right. Let's see if I can make this behave itself. Share PowerPoint. Make PowerPoint do this. All right. How are we doing there? Is that everybody seeing the slides?
Yes.
Perfect. Well, good. Well, thanks everybody for tuning in today. As I said, really happy to have the opportunity to talk to you all. Wish we could do it in person. I would say, looking here, March 5th was the last airplane I was on in 2020, so that's weird. It's been a long time since it's been a year not being on airplanes, so hopefully we'll get some vaccine rollout and whatnot and be able to start having in-person events soon. And what I want to talk about today is some things, trends that we've seen where there is a lot of focus right now on security in CI/CD pipelines, which I broadly think is an excellent thing. Everybody talking about shifting left, again, I think a really valuable and important trend. But we've also seen a little bit of what I'd call like DevOps fundamentalism or DevSecOps fundamentalism, where if it doesn't go in the pipeline, maybe it's not getting the focus that potentially it needs to if you want to look at a balanced software security assurance or SSA program. And so want to again talk about some of the cool kids thing that we've seen folks doing. Talk at a high level about what an SSA program is, or software security assurance program. Talk about this concept of fast and slow. What are the things in app security that you can do fast, or where you can drive with a lot of automation and very quick cycle times? But what are also the things that just by their nature are slow, important, but also slow, where you can't expect to use or benefit from a lot of automation, but there's still work that needs to get done. And then I'm going to walk through, using the OWASP SAMM as the background, walk through the various business practices in SAMM and talk about what parts of those are sensible to look at automating and doing fast, and that potentially fit in some way inside of a pipeline, as well as what are the things that you're just realistically never going to get into a pipeline. And then again, kind of wrap this up with some conclusions that we've seen, or some more specific guidance that we've seen based on folks that we've interacted with. We'll have some time at the end for questions. And so, I remember going to the DevOps days in Austin, when, especially like early on when Etsy and Netflix were really doing these amazing things to put security into their DevOps pipelines. Really, really cool stuff. Really amazing things, right? Putting security checks in the pipeline for your applications, for the infrastructure that you're going to deploy to, for your cloud environment, and a big focus on automation being king. The challenge there being that I remember one of our guys asked a question, to say like, oh, okay, cool. Well, you've got all these testing. How are you doing testing for potential authorization issues in your pipeline? And got like the two shoulder salute of like, we really haven't, that's not really something that we've tried to address with this stuff that we're doing. And so that's the concern there, is that, again, while there are really amazing things that you can do, there are things that don't fit well into a pipeline, but things that are important to do from a programmatic standpoint. So, what sort of stuff doesn't fit into a pipeline? And that's where I want to talk about those kind of the danger of this DevOps fundamentalism, where you're looking only at what are the things that we can fit into the pipeline, and understanding that the pipeline isn't a program. There's a lot of stuff that doesn't fit into a pipeline, especially like non-testing activities. And there's also realistically lots of types of testing that you can't get into a pipeline as well, when you look at things like what is the time budget for security in this pipeline. So if we want to look at, we want to talk about SSA programs. Look, this I don't know, everybody's hopefully at this point familiar with the Simon Sinek talk. If you've seen this like a million times before and you're rolling your eyes at this point, that's totally acceptable. But just because something's maybe overused a little bit, I think it's interesting to think about this before you start looking at what you're doing in your program. And kind of the point of this talk, if you haven't seen it before, certainly worth looking at, is focusing on your why. Right? Like, why are you starting your SSA program, right? Because all too often people focus on the what, right? Where you're like, hey, I saw this talk and we're going to, implement, static analysis in our pipeline. And that's what we're doing for security. The question you need to ask first, though, is like, why? Why are you, rolling out an SSA program? Why are you evolving your SSA program? And if you're a paper manufacturing company, you're probably going to have a very different answer to that question than if you're a large bank holding company where you're subject to all sorts of regulation, right? So it's important that you have your why, and the why is the reason for the starting. Why are you starting your program, and what are your goals that you're trying to achieve? From that, then you can talk about the how. How is the activities that you're going to undertake, right? And that's why we're going to talk through both OpenSAMM and BSIMM as templates for what a software security assurance program could look like. And then finally, you're gonna answer your what, right? And those are the specific implementation of those activities, right? So if we look at CIC automated testing, for app security, that's going to fall into that category. So rather than jumping to saying, like, I saw this neat technique, we're going to implement CI/CD testing, security testing in the CI/CD pipeline. There's a little bit of work that you probably need to do before you get to that point. If you want to end up where is appropriate for your organization, right? For the level of security, the investment that you're making in security, the types of security outcomes that you need to see. It helps a lot to go, why, how, what, as opposed to starting on the right side of the equation and doing the things that are convenient. They're not necessarily going to lead to the outcomes that are, the most appropriate or beneficial. So what is an SSA program? That's an acronym that we use, that we've seen used talking about software security assurance. Could also be SSI, Software Security Initiative, that's what the BSIMM folks call it, or just your AppSec program. But as everyone knows, clearly you have to have an acronym if an initiative is going to be successful. So for the purposes of this talk, we've got SSA as the acronym that we're going to use. And if your answer is like, what's your SSA program? And you say, well, we do an annual app pen test for PCI. That's not an SSA program, or at least it's probably not a very good one. Probably not going to be a super effective one. Similarly, here the security checks we figured out how to stuff into our CI/CD pipeline is essentially the answer that we've heard from some organizations that we've talked to. That's also not an SSA program. And so the danger here is you don't want to let the pipeline become your program. And I'm not saying that shifting left is bad. Again, there's a lot of talk in the industry. Hey, we're trying to shift left. I hear that all the time when we talk to organizations that are moving from, have made the transition from waterfall to agile, and are maybe looking at moving agile to DevOps, and they're saying, well, the mantra around our organization right now is shift left. And I'm not saying that shifting left is bad. I'm just saying it's not everything. Again, my point of this discussion isn't to badmouth shifting left, but it is to combat what we've seen as being an unhealthy focus that we've talked to, where they are really focused on the what of CI/CD testing at the expense of more broad concerns. So there's two major maturity models in this space that provide insight into the landscape of what organizations are doing. And really what they outline are, what are the various activities that can and should go into an SSA program. And there's the OWASP Software Assurance Maturity Model from OWASP, and the formerly Cigital, now Synopsys, BSIMM, or Building Security and Maturity Model. And they have a little bit different kind of approaches. The OpenSAMM was originally written from Prabir Chandra. That's evolved into a OWASP essentially as a fork that's pushing that forward. And they outline, here's 5 different business functions 3 security practices for each, and 2 streams for each. And that model looks like this. And these slides and all that will be available for folks. But it's really more of a describing here are as experts in the industry. These are the types of things that we've seen. We've laid out this structure. The BSIM, originally, as I said, from Sigil, now Synopsys, was based on a lot of data that they collected from participating organizations. 4 domains, 3 practices for each, and under that rolls up a total of 119 different activities. And so, and there's some mappings that have been done that show, well, here's how OpenSAM or OWASP, SAMM, and BSIM line up. Very similar, again, kind of in structure. And at the end of the day, I think either model is an excellent one, to use. They cover a lot of the same ground. We're going to use the OWASP SAMM walkthrough because this is an OWASP meeting. It's more prescriptive, it's less vendor-centric. If you're using BSIM, though, it's pretty straightforward, pretty trivial to translate. So if you're just starting out, so one thing I'll say is, and again, for OWASP meetings, maybe this isn't necessarily as much of the case, or maybe it is, but if you look at your organization and you're really just starting out in your organization on your AppSec journey, right? You're just now starting to look at this in a structured way. I'd recommend against using either tool, either BSIM or OWASP SAMM, because if you're not doing anything, right? Being told that you're not doing anything is not super helpful, right? Like if you say, well, I want to see how we stack up against the OWASP SAMM, and it's like, well, here's the oh yeah, you got a 0, a 0, a 0, a 0. It's like going to CrossFit and just getting no reps for everything you try to do. Or not meeting like a push-up standard or something where no, right? So if you're just starting out, a better approach is, again, get that why, figure out what is your scope and your mandate. And my recommendation would be to do some testing of some critical applications or applications where those teams are open to it. Run some vulnerabilities through the process to resolution, right? So, look at the vulnerabilities, do triage, figure out this is the stuff we're going to fix. Who do you need to contact? Like, what do we need to do to actually get these fixed and push into production? And then understanding the communications that came out of that, like that's really a starting point that you can proceed from. So if you're really just starting out using OpenSAM and saying, well, what do we want our security testing strategy to be, or what are our metrics that we're going to be tracking? Again, that's probably not a great place. But when you do have a program up and running, then either OWASP SAMM or BSIM are great ways to take a step back and to look more broadly at the program that you started to build, and to set some benchmarking and to set some roadmap goals for where you want to get to. So now I want to talk about this concept of fast and slow, which I have shamelessly cribbed from Daniel Kahneman. In the book, Thinking Fast and Slow. And in this book, he talks about this system 1 that operates fast, where you have kind of an instinctive or emotional response, and system 2, which is slow, which is more deliberative and logical. As we will discuss, a lot of success in making good AppSec fast decisions is actually taking the emotion or the unreliability out of the process, but keeping that instinctive nature, that fast turnaround nature to them, right? How can we provide high signal, low noise information for decision making in the case of fast? This book goes, obviously far deeper into this, and the analogy falls apart, but it's a useful model that we've seen for looking at, hey, we've got this DevSecOps initiative. Let's look what can be fast and what has to be slow. As an aside, what horrible names researchers have for giving things. Why not call it like the fast system and the slow system? Instead, we call it system 1 and system 2, or we call it system 1 and system 2, which is almost as bad as type 1 and type 2 errors. Right? Why not call things false positives and false negatives, which are easy to explain? Instead, you take all of that out and just strip it all away and make it so that only the cool kids or the kids that spend time to memorize the stuff are going to know the differences between those types of errors. Fortunately for our industry, most folks have settled on using false positive and false negative. As another aside, there's a great book called The Undoing Project by Michael Lewis that talks about the research and collaboration between Daniel Kahneman and Amos Tversky. If you came to this talk looking for book suggestions, you're really doing great this this afternoon. So kind of getting back on track. Fast and slow. So in a culture like DevSecOps that is so focused on fast, but still has to go slow. There's a blog post, and again, the deck will be available, that talks about, that I put together, that talks about like power and responsibility. What is security's role in the DevOps pipeline? And going back and looking at, if security expects to have the ability to weigh in and say, hey, we've done some security testing and we're gonna block this build from moving forward. We're gonna break the build, right? That's a tremendous amount of power, but it comes with it a tremendous amount of responsibility. And what we found is security teams that don't understand that balance of that power and responsibility soon find themselves with no power, and correspondingly, no one cares about their responsibility. So, what do we mean to be DevSecOps fast? The criteria that we look at, a couple criteria that we look at. Like number one, to be DevSecOps fast, right? It has to leverage automation and be available very quickly, right? You've got to fit into a time budget in a pipeline. Anecdotally, we've heard that a lot of times the security time budget in a pipeline usually lands somewhere between 8 and 12 minutes, just from discussing with different different groups that we've talked to. All right, if you want to fit something into a pipeline, you've got to you've maybe got 8 to 12 minutes. Maybe you've got longer in your organization. That's fantastic. Maybe you've got less. But any information that you're going to surface has to be high value, right? People have to care about what you're telling them, right? And so something like, hey, you have a publicly accessible SQL injection vulnerability that's going to be easy to identify and exploit. I would consider that to be a high value piece of information, right? Where a developer is going to say like, oh, I agree, security has weighed in on this. We need to, it's cool for us to break the build in this scenario because I want to fix this before this moves forward. The third criteria is you really need to have low, and by low I mean no, false positives or type 1 errors for the people that really like confusing terminology, right? You can't be, if you're going to do something, if you're going to block a build, you've got to be right. And so what this boils down to is you've got a limited time budget. The developers have to care about what you're going to tell them, and don't waste developers' time with by a crying wolf, right? So important stuff to think about when you look at like how are we going to, or what's appropriate to integrate into the into the pipeline. Those are the criteria that we usually use in order to make that determination. All right. So now what I want to do is walk through the OWASP SAMM structure and talk about some, what do we perceive, or what do we see that people are able to do fast? What are the things that have to be done slow? As well as some guidance that we've seen just from interaction with different organizations. And so, first we'll look at governance, which breaks down into your strategy and metrics, your policy and compliance concerns, and the education and guidance. So strategy and metrics, you can't automate strategy, right? Like, yeah, I wish you could. That would be fantastic, because that's really asking your question of why are we doing this, and how are we going to be doing it, right? So those, by their nature, those are decisions that you're going to make specific to your organization. And when we look at metrics, that is an area where you can be kind of fast, where you can use your CI/CD your pipeline to feed the metrics that you're collecting across your organization. And so again, strategy is slow. You may have activities that come out of your strategy that are fast. And again, CI/CD can feed into this. And again, the best metrics are you want those to be as automatable as possible. It's hard enough to do security metrics if there's a giant set of manual processes associated with it. That's going to really limit your success. When we look at policy and compliance, you can't automate the creation of your policies. You've got to understand what is our regulatory environments, what are the policies that we're going to use. You can, however, use CI/CD to automate certain policy checks, right? You may have security tests that are going to have those clear characteristics, or those provide a clear signal, like, hey, we know this build is not going to work because this is going to be outside of the range of policy, so we can potentially fail. We can potentially pass or fail based on that. Again, remembering that power and responsibility balance, and I think it's also important to understand the limitations of this, right? The types of checks that you can automate for policy checks like this, I view those as a helper to the overall process, not something that is definitive. And so policy and compliance, you can make kind of fast for checking the implementation or your compliance with certain policies. Again, but determining the policies that you're wanting to be compliant with is something that is going to have to happen before that. When we look at CI/CD policy configuration, we look first at testing, right? And you're going to have two types of testing: this synchronous testing, where all of the testing will be done as part of the CI/CD pipeline, as well as asynchronous testing, right? Just because you're not finishing an activity inside of a pipeline, it's great to use pipelines to automate kicking off those processes. You just need to make sure that you've got that process also includes, how do I asynchronously pick up the results of this? And if we've found something that is serious, to go back and address that. Then you could potentially make some sort of a decision, again, based on the results of synchronous testing, to say, we did these tests and we have a clear signal that says we're going to go or no go, and then you need to report. And typically, it's best to report this back, into the CI/CD pipeline, as well as potentially into whatever ALM system you're using, if you're using Jira or something like that. We look at education and guidance. Instructor-led training is the slowest of activities. It can be tremendously valuable, if targeted at dev teams, with good instructors, good content. It's a really valuable activity. But obviously, to have an instructor, go in and train developers and other analysts, that is slow. E-learning. Is also, especially the kind of more monolithic approaches, can be slow, but we've seen some really interesting things from certain vendors that are doing more like kind of vignette or very targeted stuff. And so that's certainly an area where you can say, hey, if we ran some testing and we found a certain type of vulnerability, we can potentially push that developer to some content relevant to whatever mistake they may have made along the way. So that's there's some interesting things. Again, it's not necessarily fully, it's obviously not fully automated. But that is something interesting that we've seen as a way to deliver knowledge to developers in a very targeted way. We also do a lot of work with security champions programs. Actually, John Dixon just finishing up a big survey of a number of organizations to gather data about their security champions programs. So that stuff will be delivered here, or we'll be publishing that here before too much longer. And what we see is a lot of organizations, like an important responsibility for security champions is to help configure security into CI/CD pipelines. And so security champions can help make things faster. Obviously, it's them doing work. Security champions are not automated, but a very common responsibility that we see for people in a security champion's role is, we're moving at a certain speed, we need to move faster, right? And it's your responsibility to start getting things into the pipeline in order to address this stuff. We also have a previous webinar that we did. There's a link out there if you want to take a look at that. That'll be a good precursor to John Dixon's research that he'll be publishing here shortly. Now, if we look at design, threat assessment, security requirements, and security architecture. And so from a threat assessment standpoint, determining your general application threat profiles can't really be automated, but there are some interesting things going on with OWASP Threat Dragon, as well as some other commercial vendors that that are looking at how do we make this threat modeling process, how do we make this run a lot faster. It's not necessarily something that's going to go into a CI/CD pipeline, but there is some interesting automation that certain folks are providing tooling support for. But in general, again, threat modeling and threat assessment is a process that is happening outside of a pipeline. So security requirements, again, determining your requirements is largely manual. As I said, there's certainly overlap between a lot of the projects or products that folks are using to help, make threat assessment and security requirements more scalable. But again, this is something that is happening outside of the pipeline. In the pipeline, you might be validating that you have met certain aspects of your security requirements. And we'll talk more about that when we look at the verification session, talking about requirements-driven testing activity. Secure architecture, again, architectural security requirements, largely manual and slow, but you may be able to, validate certain constraints that you have on your secure architecture as part of a pipeline. That's something we'll talk a little bit later about verification when we talk about architecture assessment activities. From implementation, you want to make sure, how secure is your build, how secure is your deployment, and how are you handling defect management. So, the secure build, this is really at the foundation of what we're talking about today, right? Because that's fast, right? You're talking about your CI/CD pipeline. How do we continuously build and potentially deliver software and do that in an automatable, templated and scalable way? And so what we're looking at then is, well, how do we integrate security into this build process? XAST, static, dynamic, interactive testing, software composition analysis. I'll give a call out to the OWASP dependency check project, which is a top level project, really great at looking at the, as you're with your build process, what components are you bringing in, and do those have known vulnerabilities with them? All right, if you're even considering this, if you're even considering using any of the stuff we're talking about in this discussion today, you really, have to have this repeatable build process. Otherwise, maybe you take the rest of your lunch break and get a Jenkins for Dummies book, and the recording will be available, right? But the secure build is really at the heart of, or the core of, what we're then trying to attach security activities to this build process being done in a repeatable process. I'll also call it another OWASP project. OWASP dependency track is related or similar in that it's looking at component versions that are pulled into software, but it's more focused on software builds and materials, right? Being able to answer the question for this given build of the software, what are all the components that we included? Again, I definitely recommend taking a look at dependency track, just like dependency track, fantastic OWASP project. And I'll also call out, as we move into more cloud native development, I've been talking with a lot of folks about this concept of an architectural bill of materials. All right, it's certainly important to know for a given piece of software what are all the open source components that have been rolled into this. But if we look at cloud native development environments where you've got multiple containers running multiple web services that all connect together, microservices and whatnot, you need to expand that so that architecturally what are all the components that I have used to build this running piece of software. With a monolithic piece of software, it's easy to say, well, here's all the open source components, here's all my code, and this thing is running on a server doing one thing, right? In that case, having a software bill of materials goes a long way to letting you know what's running. In a cloud native environment where you've got microservices, multiple containers, multiple code bases that are running in conjunction with one another, you need to take a step back and look to see architecturally what are all the pieces that I've included and what are those properties. So for secure deployment, that's an extension of the secure build. Organizations that we've seen tend to be a little less mature here, just because organizations, again, from a secure build standpoint, right? Everybody needs to build. Not everybody is necessarily doing deployment into production environments or continuous delivery of software. Again, it's going to depend on what your organization looks like, the type of software that you're developing, if it's packaged software that gets delivered versus as a service software. But there's a lot of great technologies here like Puppet, Chef, Terraform that can help make sure when you get an accepted build of software, how do you transition that into a production environment? Next, looking at defect management. Subsets of this can be fast, right? But you have to tune your scanners or you're going to run into problems. And as I've talked about before, you need to have high value results. and no false positives, right? So if you want to automate the creation of defects as part of your CI/CD pipeline, again, they have to be impactful answers that the developers are going to want to take action on those, and you can't have false positives. Otherwise, that automation is going to get pulled out. And what we've seen in practice is automatically creating defects, given different packages, given APIs for automation. Automatically creating defects is technically very straightforward. In practice, it takes a while to get to this level, again, because you have to understand your scanners, how they operate in your environment, have them tuned so that you're only running rules that provide those high value, no false positive results. And it's kind of a crawl, then walk, and then run progression that we see in most organizations. And again, this is something where it makes a great demo to say, like, look, we ran the scan and we found stuff and we bundled things and we created defect. Look, end-to-end automation. Great, love it. But for that to be practical and operationalized, again, high value, no false positives. And this is going to have limited coverage, right? It's only going to work for vulnerabilities that you can find with automation and CI/CD pipelines. And in the verification discussion, we'll talk about, like, here are the limitations that we've seen with the type of testing. Back to that original question that I talked about, that question from DevOps days way back whenever, like, neat. I see the types of things that you're automating. What about checks for authorization issues, right? Or business logic issues? Those are the types of things that you can't automate with, or at least not with current technologies. Maybe somebody's going to make some sort of AI, machine learning magic that does that, and that'll be great. With the state of the industry right now, that's not. You're only going to be able to automate defect management for the subset, or for a subset of the types of vulnerabilities you're going to be finding. What are your bundling strategies for turning defects, vulnerabilities into defects? Taking one vulnerability and turning it into one defect. You run the risk there of spending more time administering each defect than actually fixing things. Back when we went to offices and we walked through parking lots, I used to joke that if you take this approach, you run the risk of your QA manager trying to shiv you in the parking lot. Less of a concern now. I guess that's one additional good thing in the pandemic is it's harder for the QA manager to come and find you in the parking lot because you never go to the parking lot. So you really want to look at bundling strategies. The most common here is bundling by vulnerability type. If you think of, well, hey, I've got a bunch of cross-site scripting vulnerabilities. Well, cool, let's bundle those into chunks of some sensible number, 20, 25 or something like that, maybe fewer, maybe more. Let's bundle the vulnerabilities of a similar type together, because to fix those cross-site scripting vulnerabilities, the developer is going to be using the same library, the same set of encoding functions, and they can just say, like, oh, okay, well, here's my list of 10. Number 1, encode. Number 2, encode. Number 3, encode. Work way down the list. With more mature applications, right, where we don't have a lot of a backlog of vulnerabilities and new vulnerabilities coming in, or that's hopefully a less frequent occurrence, you may want to look at bundling things by severity. Say, well, hey, this last run, we found 1 critical, 2 highs, and 4 mediums. We're going to go create 3 tickets based on that, and the developers are going to go and run those down, in that order. That's an approach that we've seen work, but again, with more mature applications where you've been through tune the scanning, you've worked through the worst of the technical debt and the backlog, and there may be other approaches. Some applications that you may say, well, hey, so and so wrote the checkout process, and whenever anybody else touches that, it breaks. Not ideal, but it happens. So let's bundle, and anything that is in this part of the application, we're going to bundle those together and give that as a user ticket to the developer who's responsible for that stuff, whatever that might be. And so also we see having a metrics and a feedback stream, right? For OpenSAMM, right? Which is like, what are we seeing? What practices are we seeing? And it's important to have a separation of duties. To my perception, with programs that we've worked with, there's always questions about, like, what rights or what abilities should developers have to weigh in on things being false positives, or to weigh in on severity, or to say that something has been closed out. I like to see, or what we've seen that works well, is you have a separation of duties between the scanner, the testing that finds the vulnerabilities and characterize them, and the developer that says, like, it's my responsibility to fix them, because then that allows the scanners to go and confirm that they and obviously this only applies to vulnerability identified by automation, but that avoids a situation where you hand a bunch of vulnerabilities over to the developer and they're like, those are false positives, right? Like, we'd never see that behavior in production, just close this out, it won't fix, right? That separation of duties between finding the vulnerability, fixing the vulnerability, confirming that the fix was successful, that is helpful because it, it provides that separation and avoids some potential bad dynamics. Also, from a metrics standpoint, I like one of the metrics that I really like looking at is your mean time to fix or your mean time to remediation. Right, defects per kilo line of code is very easy to calculate, which is which I guess makes it half of a good metric. But when I'm looking at Agile and DevOps teams, a real question is, how fast can you fix? Like, once something gets introduced, how quickly can you get rid of that vulnerability and get it and get that fix pushed out to production? Especially looking at high impact, critical high, maybe medium vulnerabilities. And this is also an area where the folks from Veracode and from NTT White Hat had published a lot of data. Veracode's state of software security, the White Hat application security statistics publications that they make. Great way to look and see, like, hey, what are the remediation times for organizations you might consider to be a peer in your industry? Okay, now we get to verification, and this is where a lot of the discussions about fast and what fast can be, what tasks can be fast comes in. And this implementation is going to provide the setup in the automation framework, right, for your secure build process, that repeatable build process. Now we need to look, what parts of this verification can be automated? Which of these can we make fast? And looking at this both from an architecture assessment, from your requirements-driven testing, as well as your more broad security testing. Architecture assessment, largely has to be done manually. There are certain policies that you may be able to check automatically. Looking at like cloud configuration, there's a great tool called ScoutSuite that does a lot of checks for cloud environments to identify, do we have open S3 buckets? What does our identity and access management configuration look like? And so there are, if you have assumptions about the architecture as it goes into implementation, there are certain things that you can check with automation. When you look at the requirements-driven testing, this is the control verification, largely a manual process, runs slow. Misuse and abuse testing, fuzzing can be automated, but the nature of fuzzing, unless it's, you could argue that DAST testing is directed web fuzzing, and you'd be correct, but just kind of broad, if you're looking just broadly at fuzzing binaries or something like that, it's easy. There are a number of frameworks for automating this, but the runtimes are probably going to run, extend beyond the time budget for fast. You're going to want to be checking these large, permutations and combinations of potential inputs. If you look at your abuse case and business logic testing, that's manual. We've seen people try to automate like Selenium tests or things like that for problems, known business logic issues and things like that. Those tests tend to be pretty brittle, in that they're looking for a specific way that this was implemented wrong in the past. But as the code base changes, those tests may break, and you're not then getting additional coverage for new ways that that particular business logic issue might break. Denial of service testing doesn't fit into most pipelines either. Some automation integration is possible, and one of the things I've seen, I've seen some examples of people trying to do like cross-site scripting with like unit tests, and that was interesting kind of the first time I saw it, but to test for those types of issues, there are typically better tools like static or dynamic or interactive analysis versus coding specific test cases, right? What you don't want to do is make these tests so specific that they're not generally helpful enforcing requirements, but instead just add to the amount of test code that you have to maintain over time. So for security testing, this is where the discussion really, what the discussion really comes down to, and how sufficient is the security testing good stuff into a CI/CD pipeline. OWASP SAMM looks at two separate streams, your scalable baseline and your deeper understanding. And so OWASP has traditionally had, I've been involved in OWASP for probably 15 years. And there is a culture, which I think is very good in OWASP, toward tool and vendor neutrality, right? And I think that's great. That fits very well with OWASP's mission and whatnot. There's a bit of a dark side that can come along with that, which is like vendor and tool hostility, which is probably less productive. And I think it comes down to a lot of the folks that shaped the culture of OWASP initially came from a consulting background, as I do, versus the scanner vendors. And so that's just something I've seen, again, being involved in OWASP for a number of years. And what you see is that a lot of the great publications from OWASP, such as the Testing Guide and the Application Security Verification Standard, ASVS, those do a great job of highlighting here is the breadth of testing that can and in different situations should be done, and here is the insufficiency of automation to totally meet these challenges, right? And so again, that's just an observation that I've had about kind of OWASP. If you look at the OWASP tools and the conferences and whatnot, can be a little bit tool or vendor hostile from time to time. So if we look at this scalable baseline stream, there's three levels of maturity. First is the use of an automated tool. Second is use of application-specific automation, which is tuning. And finally is integration into the build process, right? And you'll notice that the way that the OWASP SAMM folks have characterized this, right? You can't jump to number three, or it's from a maturity standpoint, you can't go straight to number three, right? First, you have to use an automated tool and understand what results are coming out of that. Make sure the tool understands the code base for SAST, understands the how it's going to be doing its crawling and fuzzing for DAST. Right. The next step then is to tune that for a particular application. Right. So again, if it needs training in order to do the crawl process, if you've got to turn rules on, turn rules off, if you've got to script the way that code gets stuff in your code analyzer, whatever that might be, right? At that point, then you can integrate it into the build process, right? And so again, the way that the OWASP SAMM characterizes this is very much in line with what I had been characterizing our perspective on this, which is, right, you want to make sure that you've got those high quality, high impact and high quality results. And at that point, you can start to put it into the build process. If you just take XYZ scanner tool and drop it into the build process, you're probably not going to get a lot of, you're probably not going to get the kind of value that you want out of that, right? Instead, before you do it, you've got to tune your dynamic scan, you've got to call your SAST rule set and so on. And so this webinar, like the stuff that we're talking about here, presupposes that top level of maturity, right? Because without that scanning, you're going to be producing results that are potentially suboptimal. And then the deep understanding stream of testing. This is all manual, right? Manual testing for high-risk components, performing penetration testing, integrating testing into the development process. Obviously, tooling can help with this, right? Because you can do things to say, well, let's look at the code that has changed. I want to focus on efforts. I want to focus my limited testing efforts on changes in the applications, new functionality, altered functionality. So there's some tooling that you can put around this, but this deep understanding stream of security testing is all manual, right? It's checking the business logic, that understanding of the application and knowing, for this application, a certain behavior is acceptable. For another application deployed in a different context, that same behavior may not be acceptable. So now let's look at testing in CI/CD pipelines. So static analysis in CI/CD pipelines. The success that we've found here is typically the more open source type of linting static analysis tools that are doing like semantic analysis of applications, but aren't doing that full commercial grade, cross method, cross class data and control flow analysis like that analysis takes time in a lot of cases to do. I've seen some interesting stuff, coming out that is, some of the vendors claim you can run, differential SAST, which is neat. I've seen certain, scanners that can do data and control flow a little bit faster. Which is exciting to see that stuff, kind of come out. In a lot of cases, what you want to do is like cut down the rules, right? That's going to help you shorten your run times and limit false positives. Which is again in line with kind of a lot of the things I've been saying. With dynamic testing in CI/CD pipelines, always we have concerns about run times and approaches for targeting DAST. I've seen a lot of checks where you're looking for things like missing security headers based on traffic to and from the application. That's again potentially really interesting, or potentially interesting in your environment. It's also easy to easy to test for, with high confidence in the results. We also played around a couple of years ago with focusing on changes, only doing dynamic testing of the changes in the application. And again, in the this is a webinar talk that I gave at a couple different OWASP events, looking at like here are some techniques that we've got to say between check-ins of code. Here's what the application attack surface used to look like. Here's what it looks like now. Here's the stuff that is new. Here's the stuff that is modified. Let's focus our dynamic testing specifically on new stuff and potentially modified stuff as well, because that's where we would most expect to find security vulnerabilities. Looking at IAST and CI/CD, I think that's fantastic. Those are typically going to rely on some sort of generated traffic. And so you've got to generate traffic in the application. Maybe you can use DAST, like security DAST testing, to generate that traffic. Also, you can use your integration test to organically provide the analysis engine with this traffic. But that's an important thing to understand is, for most IAST to be effective, you've got to have some sort of something exercised in the application, so that engine can see how the application actually behaves, when it's running. Software composition analysis, running like a dependency check or something like that in CI/CD, I think that's great. The only concern that I have with that there is look at your runtime trade-offs versus like what is the velocity at which you're adding new components to your application, and what is the velocity with which new vulnerabilities are being found in the subset of components that you're using. But again, in general, especially if you're running it in parallel and it's not causing a lot of trouble, running software composition analysis in CI/CD is great. Now closing this out with operations, incident management, environmental management, and operational management. Again, incident management not handled in a pipeline, or hopefully you're not having sufficient number of incidents that you're building a pipeline for. Obviously, using automation for detection of incidents is fantastic. There's automation frameworks to run, to go through runbooks and stuff like that, for responding to incidents. But looked at specifically from a pipeline standpoint. We don't see a lot of overlap between incident management practices and CI/CD pipelines. One thing I'll also call out is my colleague John Dixon a couple years ago had published a talk and some slides looking at how is the logging that most application developers put in their applications, like how that fails to meet the needs of incident responders that are then later trying to determine incidents, and really looking at a developer is really trying to debug the state of the application at a given point in time to identify potentially erroneous behavior in the small, whereas for security logging, you're often wanting to be able to correlate between multiple different activities. And that's not necessarily the way that developers think about how they're going to instrument their application in order to, with the logging that they're doing. So that's another resource that may be of interest to folks. Environment management. I don't know who said this first, but when I heard it, it really struck me. Your servers should be cattle, not pets. I remember at my first company, we had all of our servers were named after diseases or biologic agents. So we had Hanta and Mataba and Ebola and whatnot. All the The servers, in college used to be named after planets and stuff like that. Like, in the intervening years, now when you can spin up like 100 servers in Amazon by clicking a button or running a script, again, your servers should be cattle, not pets. And for anybody who's really focused that much on CI/CD, again, talked about how the maturity from a secure deployment that lags in certain cases, but hopefully, again, with your configuration handling stream, hopefully you got this sorted out. Chef, Puppet, Terraform, ScoutSuite to do checking and things like that. For patching and updating for that work stream, hopefully you've got the scanning in place so that your detection goes very fast. Still we see, again, with patching, a lot of organizations it's still being slower in that practice, just with the concern that if you go applying patches, things may break. Operational management, your data protection stream is slow. Wait, you mean my DLP solution won't sort this out for me? And obviously decommissioning of applications as a whole. This is really looking at grooming your application portfolio. That process happens slow because you've got to make a business decision to say, this application is no longer going to be in our portfolio. We're going to turn this off, and some users are no longer going to have access to that. I've been in some extremely enlightening, but also terrifying conversations around conference tables where people say like, oh, well, that XYZ application is, we turned that off. It's like, no, we didn't, because we still have the extra version running for that important customer where we cut and pasted all the code, made the changes they wanted. We can't turn that off. We've got a service level agreement and a contract that we've got to keep that up for the next 5 years or whatever it might be. And so again, operational management, this is, these are not things that, lend themselves to a lot of automation. So in conclusion, to kind of sum up a lot of the stuff that we've talked about, what goes in a pipeline? Linting SAST, DAST if you can target it, IAST if you can generate meaningful traffic, software composition analysis if you want. What are the things that likely have to be done outside? Full kind of industrial commercial grade static, full crawls and fuzzing runs of DAST, manual code review, penetration testing, threat modeling. And what are the other things that need to be done outside? And that's pretty much everything else, right? Your strategy, your policy, your developer training, architecture, and security requirements. And so shifting left is awesome, right? But it's only one aspect of a far more complicated landscape. And so in support of this, I think for testing, I think of in a coverage model, right? You've got different classes of vulnerability, you have different detection approaches, and those detection approaches have a different level of effectiveness or quality. And so for a given application that exposes you to a certain amount of risk, right, you're going to say, here's the types of things I want to be able to find, right? I want to be able to find SQL injection, cross-site scripting, and I want to be able to find authorization issues. Okay, what are the detection approaches? Hey, we can do linting SAST in in our pipeline, and that's going to catch certain SQL injection and cross-site scripting signatures. But for other situations, we're going to need that longer run of a SAST or a DAST tool. Because because I need that further analysis to detect other certain signatures. For authorization stuff, I'm not going to, I can't detect that with automation. Therefore, I have to have periodic pen tests in place to identify these potential issues either before release or on a periodic basis. And so that's the way I look at it, is from a testing coverage standpoint. An application that has certain characteristics, is going to be exposing you to a certain type of risk, and you want to make sure for the depth of coverage that you need, you have overlapped your tooling and your other practices in order to get the level of coverage that you that you want. And for the other things, again, take a step back, understand your why. Understand from that, like, how does that then generate or lead to your how, and then from your how, that then should drive the what, right? Think programmatically about these things. So now I'll open stuff up for questions. I think there's been a bunch of activity on the chat. Let me,
Yeah, there's a lot of activity. I don't see necessarily questions, but if people do have direct questions, I mean, the last thing was a question, but everything else is kind of discussion and people wanting your slide deck. It seems to me like that's like, yeah, we want to see that video. Can I see that? So if you can either post it or send it to me, and I'll post it with this stuff, that'd be great too.
Perfect. Yeah, I'll get it over to y'all, and you guys can get it up.
Does anybody have any direct questions for Dan?
And when you said within OWASP, especially, before, ancient years, like, probably 8-10 years ago, there was the kind of politics anti-tool. Do you mean that there was more of a consulting bias? I was just a little confused.
That was my perception. I think a lot of the organizations, I mean, and we participated in this, the AppSec folks and whatnot. I think a lot of the organizations that were really driving a lot of the, it started the early projects, started things like the testing guide, ASVS and whatnot. Those folks came out of the consulting firms and had a consulting firm perspective on, what an application security program looks like, which is not to say that that is correct, right, or 100% correct. I just, that was something just where I perceived that was the bulk, right, or a majority of the involvement was driven by a lot of folks from the consulting side, and therefore, the answers that you get when you ask questions are going to be the answers that you would get from a consultant, talking a lot about manual and whatnot, versus
billable hours.
Right. Exactly. Right.
Makes sense. Thank you for clearing that up. I was just a little confused.
Yeah, and others may disagree with me, and it's again not to say that the tooling vendors have not been involved and provided tremendous contributions to OWASP, but just from a bias standpoint, and again, I think it bears out looking at things like the testing guide and ASVS. They do a great job of capturing here's what tooling can find, but here's also, let's make sure not to forget that there are a number of things that tooling can't find, and as part of a broad or comprehensive approach, back to that discussion of coverage, which is a super consultant answer. If you want to look at coverage, you're going to have a number of non-automation activities that will be in the mix.
Thank you very much, Dan. And I noticed we had 50 participants. I think that's a new record for these virtual meetings. So really appreciate you. And I will be quiet now and see if there are any other questions.
Hey, Dan, real good talk. I did throw into the chat kind of the OWASP roadmap, integration roadmap, which is a really good resource to walk through the SDLC and see what different tools or processes you need to build. I think you covered almost every one of them. And that's a real good resource because it's been updated in the last 6 to 8 months, I believe.
Oh, good. That's fantastic. Very good. Yep. Project integration standards. Very good.
Anybody else with any questions? If not, we can actually wrap up early. That was a great amount of information there, Dan. Thank you for everything. Thank you for doing this for us again.
Nate, thank you all very much for taking the time to listen to me. I hope everybody survived and to the degree possible thrived in the great Texas snowpocalypse of 2021.
Very true.
And again, yeah, it's been a wacky last year, and I think we're all fortunate. I think a lot of us in this industry. I think what we do is very remote doable, which I certainly consider myself, have a lot of gratitude and feel fortunate. Hopefully, everybody's stayed safe and healthy through all of this, and looking forward to when I can get back up to Austin and see folks in person.
Thanks, Dan. Thanks, everybody.
Thank
See y'all.
you.
We'll hear from everybody at the end of March for the next chapter meeting. So have a good day, y'all. Adios.
Awesome
Thanks,
stuff.
y'all.
Thank you all.
Bye.
Take care, everyone.